Example 3, you work in a grocery store and are stacking apples in the shape of a square pyramid with 7 layers. Write a rule for the number of apples in each layer, then graph the sequence. So just so you can visualize what they're talking about, this pyramid of apples, in the first layer at the very top of the pyramid, there's just one apple. So this would be A sub n. So in the first layer, there's one apple. In the second layer, it's a pyramid, so it has to get bigger. So now it's a 2 by 2, so there's a total of 4 apples. In the third layer, it's 3 by 3, which means there's a total of 9 apples. In the fourth term, it would be 4 by 4, which is 16. So what is the rule for A sub n? Well, you take n and you square it. So that's the rule that they're looking for. So not all rules are created the same. Some of them are a little more straightforward. So some of them are not. But when they say graph, they want to put n on the x-axis and a sub n on the y-axis. So when n is 1, a sub n is 1. So I'm going to make a point. When n is 2, a sub n is 4. So I'm going to make a point. When n is 3, 5, 6, 7, 8, 9. A sub n is 9, so I'm going to make a point. And then when n is 4, it's up to 16. So it's going to have kind of a curved shape. Now, I actually don't know if I want to attach that because I don't have a second, like 2.5 layer or something like that. So I actually think I just want 5 points. But it's going to have that curved shape. So if I wanted to know how many were in the 7th layer, I would take 7 squared and say that there are 49 apples in that layer. If I wanted to know how many total apples are in all 7 layers, I can add them all up, which is exactly what I'm going to have to do, but it introduces this concept of a series. So when the terms of a sequence are added together, the resulting expression is a series. So a sequence is just a list of numbers. These are all sequences because they're just lists of numbers. A series is all added up together. So it can be finite, 2 plus 4 plus 6 plus 8. Boom, that's a finite series. Or it can be infinite, 2 plus 4 plus 6 plus 8 plus ... which means recognize the pattern and keep going forever. 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14, etc., etc., etc. So you can use something called summation notation to write a series. And so instead of writing 2 plus 4 plus 6 plus 8, I want to be able to give it a more mathematical approach. And I want you to be able to read it and recognize what it means to do. So I didn't type this because I didn't, you'll see after I write it. So go ahead and write it down with me, and then we'll talk about what it means. So the capital Greek letter sigma. So it's kind of an E, but it's kind of got a curve or a bracket to it. You can Google how to write Greek letter capital sigma, how to write summation notation. You can get some good ideas. In the bottom, I'm going to put I equals 1. So it's an I equals 1. And on the top, I'm going to put 4. And then off to the side, I'm going to write 2i. And here's what this means. It means that the first term, there are 4 terms total. So I'm going to go from the first term to the 4th term. And what is the pattern? 2i, which means I take 2 times that term. So 2 times 1 is 2, 2 times 2 is 4. So writing the rule. So this is the rule right here that goes there. And this is the first term number. So first I'm plugging in a 1. I want the first term to the 4th term. And so that's, then the summation means I want to add them all up. The sum means I'm adding them all up. The only difference in the infinite series, I'm still going to draw my capital sigma. I is still equal to 1. And the rule is still 2i. But there's no limit to the last term. There is no, you're only going to the 4th term or you're only going to the 25th term. You're going on forever and ever. So up here, I'm going to put an infinity symbol. So you can Google how to practice writing infinity symbols, or you can turn your computer or your paper, I'm writing on a computer, and you can just draw 8s, but the infinity symbol. So notice the difference between what made it an infinite series versus what kept it a finite series. So for both series, the index of summation is I. That's just a term. And the lower limit of the summation is 1. Notice that in both cases, you started with the first term. You don't have to start with the first term. The upper limit of summation is 4 for the finite series and infinity for the infinite series. Summation notation is also called sigma notation because it uses the uppercase Greek letter sigma written how you just wrote it. So practice if you want to. Google that in your spare time. Summation. But you're not taking a test on paper, so I guess you don't really need to write it for me because it's just going to be on the computer. That means summation. So if you see that on an ACT or something like that, it means add them all up. So it says write each series using summation notation. So the fact that it uses summation notation means that I want this capital letter sigma. So then I want I equals the first term, and then I want to know how many terms do they want total, and I also need to know what the rule is. So 250 is not the fourth term because of that dot, dot, dot. So the first term is 25, the second term is 50, the third term is 75. So it looks like they took 25 times I, where I was first 1, and then it was 2, and then it was 3. So what is 250? What term number is that? How high up do they want you to go? Well, I can use some simple algebra here. 250 is the 10th term. So I want to go from the first term to the 10th term, and I want to add all those up. So 25 plus 50 plus 75 plus 100 plus 125 plus 150, etc., etc., etc. But what they're asking you is to write the summation notation, which is what I have right there. Okay, letter B says 1/2 plus 2/3 plus 3/4 plus 4/5. So I'm definitely going to need the summation notation. I'm going to start with the first term. The first term, because they give me the first term is 1/2. The second term is 2/3. The third term is 3/4. The fourth term is 4/5. First of all, notice that I'm adding dot, dot, dot. There's no end, which means that up here, the upper limit of the summation is going to be infinity. I never stop. It's an infinite series. Now I have to decide what they did, and I'm going to use the letter I instead of N just because that's what they were doing, though you don't have to use I every time. That's just to practice here. So the first term was 1/2. So it looks like they took I and they put it over I plus 1. The second term was 2/3. So I over I plus 1. 3/4, I over I plus 1. So what it's going to look like is this, which means I want to take I over I plus 1, so 1/2, 2/3, 3/4, 4/5, 5/6, 6/7, 7/8, etc., etc. Add them all up until infinity. I believe if you make it to Calc 2, you will learn about what is this? How do I solve it? How do I find the summation of an infinite series? We're not doing that. We will find summations of finite series, but not infinite. Because that gets to limits, and that's not what we're doing in this class. Okay, so again, practice, run the summation notation, and then we'll go over the answers together. So I'm definitely going to have a sigma in each case. Start my solve up. I'm definitely going to start with a 1 in each case. And then I have to decide what I go to. Well, in B and in C, I go to infinity. In A and D, I have to decide how many terms they use. So the first term is 5, the second term is 10, and the third term is 15. So the rule is 5i. So I have to say, what term is 100? It's not the fourth term. 20 is the fourth term. 25 is the fifth term. So what's 100? What term number is that? 100 divided by 5, 20. So I is 20. Which means I'm going to go from 1 to 20, from the first term to the 20th term of the pattern 5i, and I'm going to add them all up, which I'm not going to do. You could, if you're really bored, take 5 plus 10 plus 15 plus 20 plus 25, etc., etc. That's not what I'm asking you to do yet. All right, letter B, I have to decide, okay, so how did they get 1/2 for the first term, 4/5 for the second term, 9/10, 16/17. If it's a fraction, I think I'm going to break up the fraction into the numerator and the denominator and figure out, well, what is the numerator and then what is the denominator? In each case, if you're just looking at the numerators, it is the term number squared. So the first term, 1 squared. The second term, 2 squared. The third term, 3 squared. Works. And then the denominator is just 1 more than that. So I squared plus 1. So the summation from 1 to infinity of I squared over I squared plus 1, which you would need, it could just be that they add up to be infinity, but they don't always, especially with fractions like that. But again, we're not in calculus. Okay, so letter C is infinite, so it goes on forever. I have to decide what these are. So it looks to me like the first term is 6, obviously. The second term is 36. 2, 16, 12, 56. These are powers of 6. So they took 6 and they raised it to the I power. So it's not like they took I to the 6th power, they took 6 to the I power. So 6 to the first, 6 to the second, 6 to the third, 6 to the fourth. That one will add up to the infinity. I have no doubt about that. Okay, letter D, 5 plus 6 plus 7, all the way up to 12. So it looks like the first term is 5, the second term is 6, and the third term is 7. So what are they? Well, they're adding 1 each time. So the fourth term is 8, the fifth term is 9, the sixth term is 10, the seventh term is 11, the eighth term is 12. So it goes from 1 to 8. And it looks like they took I and they added 4. So they took 1 plus 4 to get 5, they took 2 plus 4 to get 6. So that might be an easier way to come up with the fact that 12 is the 8th term. But that would be the summation notation for that one. So I would read this as the summation from 1 to 8 of the quantity I plus 4. Summation from 1 to infinity of the quantity 6 to the I power.